Imagine a world without generics. We would have a list like raw, and you can add anything to it. So since you can add anything to this raw list, you can add a string and you can also add an int. And this is risky. Why is this risky? You'll see right now. So we have a string called OK, and we're getting the 0th element from raw, and we're assigning it to OK. And then let's print it out and see what happens. Okay, so it just prints out hello at the bottom. You can see that. So now let's do something else. Let's do like this. Let's do a string crash equals raw 1 dot get. So now we're getting the first element and trying to cast it as a string. So let's see what happens. Okay, so you have an exception, cannot cast. Anyways, it's a runtime exception, as you can see. So without generics, a list can hold anything. The compiler can't protect us. So we need to manually cast. If the manual cast is wrong, then you get a runtime crash. Okay, so this is where generics come in. Let's erase what we have so far. Okay, so here we have generics, string. So the list has its generic type string. And then we try to add 1, 2, 3, and it doesn't even let us compile. Why? Because required type is string, but we're providing a int. So this is compile time protection from runtime errors. Okay, and no cast is needed. So like string s equals words dot get 0. You see no cast is needed because it already knows the type at compile time. At runtime, it doesn't know the type, but we're going to get into that. At compile time, it does know the type. Okay, so let's look at another example now. Okay, so we have strings, list of strings. Okay. And so now I'm going to ask you a question. You can pause the video and think about, is this allowed? So list, object, objects. So we're assigning list of string to list of objects. Is this allowed? You might be thinking, oh, is a string an object? So go ahead and think about it. Tell me yes, no. Okay, well, the answer is that no, it will not compile. Look, so if I do this, it gives you an error. And it tells you basically a list of string is not a list of object, even though you might think it is. Why? Because if this was allowed, then you could do something like this. So basically, if this was allowed, you can then start adding ints to the list of strings, which would violate strings by adding ints to it. Okay. So even though string is an object, list of string is not a list of object. Otherwise, someone could add a non-string object into your list of string. Okay. So I hope that makes sense. Okay, next topic now we're moving to is, okay, so let's say we have two lists. One is a list of strings and one is a list of ints. Okay, so here we go. Okay, so what's going to happen here? So we're basically comparing get class for list A with get class list B. Okay. All right, well, it's saying true. Interesting. So it's saying list of string is the same class as the list of integer. I wonder why it's saying list of string is the same as list of integer. I'm going to tell you why in a second, even though it's unexpected. Okay, now let's look at some other example here. Do you think this will compile or no? If list A, instance of list string, will this compile or no? Interesting. It's saying it's always true. Okay, anyways, the point I'm trying to make is that there's something called type erasure. Okay, what is type erasure? At compile time, you have the type of the generic, but at runtime, you do not. So at compile time, we can see that list of string is not list of integer, and the compiler can also see that, but at runtime, which is get class, this is a runtime reflection. It's does type erasure. So actually this just becomes list, and this also just becomes list. And the information, the type is erased. So that's called type erasure. Okay, so the generic type information is available at compile time, but it's erased at runtime. Okay, you're gonna see why that's a big deal in a little bit. But keep in mind type erasure. So the compile has the type, but the runtime doesn't. Okay, so let's look at something called wildcards. So let's say we have a list of wildcard list, and then you add X to it and Y. So it's list of X, Y. Okay. So I'm gonna do a quiz question right now. Can you do this? Okay, well, it answers it for you with the squiggly line, but you're just trying to add a string to a list of wildcard. You would think you could add it normally, but actually it won't compile. Why won't it compile? Because if it's a wild card, you cannot write to it. You can only read from it. So once again, wildcard, you cannot write to it, but wildcard, you can read from it. So you can read, like, look, so object first unknown is wildcard list dot get 0. So we're reading from the wildcard list, and there's nothing complaining here. But you cannot write. So you're probably thinking, why can't I write to a wildcard list? Okay, you're going to see why right here. I'm going to give you an example that shows you why you can't. So you're asking right now, why can't I write to a wildcard list? Well, this is why. Because let's say you have a list of integers called ints, okay? And now you have list of wildcard XS, which is a pointer to the list of ints. Okay, and then X says you add a random string to it. Okay, well, you can't write to a list of wildcards. Why? Because if you could, then you would do this. You would be adding a string to XS, which is actually the same thing as ints. So you'd be writing a string to a list of int. That's why you cannot write to wildcard. Okay, simple. All right, so now the key point I'm trying to dive into now is as soon as you start using wildcards in your generics, you need to start thinking about one thing. Okay, wildcard in generic equals producer extends consumer super pattern. Okay, okay. Producer extends consumer super. You have to memorize this if you're going to use wildcards. You literally have to. It's an acronym, PECS. If you don't learn this, you're never going to use wildcards correctly. Um, and it's like built into the Java language itself. It's not just a pattern that you're like, oh, let me use it or let me not use it. This optional pattern. It's not optional. You have to literally understand producer extends consumer super if you're going to use wildcards in Java, or else you're not going to use them right. So the word producer means a specific thing. It means a list that you're going to be reading from. So it's producing values that you read. Okay, so here we have a list. So an example. Okay, so here we have um, extends animal. So we said producer extends, so we know producer extends, and it's being assigned cats. Okay, so can we, let's think, Okay. So can we get values from a producer? Can we get values from a producer? Try to answer this question. Yes, because that's what a producer does. It produces values that we can get. So we get values from the producer. And their type is animal because we have wildcard extends animal. So we know they're going to be subtypes of animal or animal itself. Okay, so let's run this example. Okay, simple, right? So that's producer extends. So producer produces things and we get them. So now let's talk about consumer. So producer extends consumer super. So consumer, okay. So here we have list of animals and then we have a consumer that has super cat. So basically this list, what can the type actually be? The real type. It can be cat or it can be any super type of cat like animal or object. In this case, it's actually animal, as you can see animal here, and we're assigning it. Sorry, I just messed up. Sorry, animal here, and we're assigning it to consumer. Animal is being assigned to consumer, and then we're adding stuff to it because it's a consumer, so we can add stuff to it, and it's allowed, and no, nobody's complaining about that. Okay, so what if you want to read something from the consumer? Well, actually, you can also read from a consumer, but you just have to make its type object. That's the only thing that works. You can't make it anything other than object because it could be cat, could be animal, could be object, and object is the only one that can be widened. They all can be widened to it. Okay. Okay, so that's literally the whole point of producer. Extends consumer super. Okay, that's done. So let's move on to the very last thing. You might be wondering, like, why, how is this actually implemented under the cover? Like, I thought a list is just an interface, right? If you're like a astute listener, you're probably thinking, oh, a list is just an interface and it has methods like add and get. Well, you have to think about this. So you have a generic type E, in the E is in the parameters and it's in the return. Okay, well, it's a lot different when it's in a parameter versus when it's in a return. That's the key reason why the PECS pattern exists, because when it's in the parameter versus the return, it's like a completely different behavior. Let's look at examples why. Okay, so here, this is the case of producer extend. Okay, so the wild card extends animals. So actually, the way the captured parameter works is that there's some unknown C that extends animal. So C could be cat or C could be dog. Okay, so when you do get and you know C could be cat or C could be dog, well, um, add needs a parameter of type C, but you can't just invent a value of unknown exact type. It requires an exact type. This requires exact type when it's a parameter. But here it can be widened. So it's different here. So in this case, it's a producer. So add needs an exact type, but we don't know what the exact type is because it could be cat or it could be dog. So you are just stuck. So that's why it doesn't work. You can't call this. But here for the get, it's more flexible because it can widen the return value. It could come back as either cat or dog. It doesn't really care. You could just widen it to animal regardless. So that's why the producer extends pattern doesn't throw compilation errors. Okay, so now let's look at the consumer super pattern and how it relates to the interface and the capturing of arguments. So consumer super, so the question mark, so the capture, which is here, sorry, it's here. So C could be cat, animal, or object, right? C could be cat, animal, or object. So why is it safe to add a cat? Because it exactly matches all three of cat, animal, or object. So it's safe. because it fits into any possible supertype slot. Okay, so what about get of I? It's more tricky because you have to the return type has to be, not the return type, like the expected return thing has to be object right here. So here consumer get zero is object because you can widen anything to an object, but you can't make it anything other than an object because of the fact that it would fail. Like if you made this animal, you could actually come back as an object, and an object is not an animal. So yeah, that's it. That's Thanks, guys.